Hello guys, I hope you all are having an extremely great day. Today we will discuss LeetCode question number 3607, power grid maintenance. So in this question we have been given an integer C. So it means that we have C power stations and each power station has a unique identifier from 1 to C. So basically we have one indexing here. Then we have stations. So these stations are interconnected via n bidirectional cables represented by 2D array connections where each element indicates a connection between stations UI and stations VI. So it basically means that we have been given information about all the connections between the stations, okay, which are one indexed. So if we have an edge UI comma VI, it simply means that we have an unidirectional edge between U and V between these two stations, okay. Right. Okay, all of these stations collectively form a power grid, which is mentioned here in the question. So all these stations, let's say stations 1, 2 and 3 are connected together forming a triangle, let's say. Also we can have other sort of connections, like we have so many stations connecting in different group, but these two groups are not connected to each other. So all of these stations collectively form a power grid as per the question. So initially all stations are operational. Also in other words we say all these stations are online. We have been also given a 2D array queries where each query is one of the following two types. So first type of query is 1 comma x, which essentially means that we are we are requesting a maintenance check on the station X because there is one, so that's query type 1, and it states that a maintenance is requested for station X. So if that station is online, it will be resolved, that check will be resolved simply. But if that X is offline, then what we have to do, we have to resolve that check by some other station which has the smallest ID in that power grid. For example, let's take an example using this. Okay, let's say we have three stations, 1, 2 and 3. Okay, now initially all these stations are online, right? So all are online, right? If we want to check on station number 2, okay, if you want to check on this, it is online, then we are good to go. We will simply return 2. But if this 2 is offline, if this station 2 is non operational, then what we will do, in this group, in this connected group, what is the smallest ID station? It is simply 1, right? So the answer then will be 1. Okay, let's take another example to get this more clarified. Let's say I have this, I'll just clear. Okay, let's say I have this station 1 connected to 2, which is connected to 3, 4 and then 5. It's like this. Okay, all the stations are initially online, all the stations are operational. Now I want to perform a query of type 1 on this station 5, right? Initially it is online, then we'll just simply return the answer to be 5, right? Now let's explore what the other type of query is. It is 2 comma x. So what are we doing? We are putting the station X to offline mode, so it becomes non-operational. Okay, great. So let's try to perform query type 2 on this station 5. Okay, so what it's gonna do, it will just put this offline 0. So I have put an X here. Okay, great. Let's perform query number 2 on station number 3 also. Okay, it is also non-operational. Now if I want to perform query type 1 on station 1, right? So my answer will be 1. Why? Because this 1 is online, so we are good to go. Now let's perform 2 comma 1, right? So it will simply put this station in the offline mode, non-operational mode. Okay, we are done with this also. Now I want to do this 1 comma 1 again, right? Now this one is non-operational. So what we have to do in this connected group, which station is online and has the smallest ID? The answer is 2. So it will return 2. Great. Now I want to do 1 comma 3 here, right? I want to do 1 comma 3 here. Now what I can do, this 3 is not online, so which is the smallest station? Again it is 2, so my answer will be again 2. If I wanted to do 1 comma 4, 4 is online, so I'll simply return 4. As simple as that. But if I am closing all the stations in a group, right, all these stations are closed here. Now if I'm querying, let's say 1, right, so I am left with no stations to return. So my answer will be -1 as per the question. We'll simply return -1. So that's the gist of this question. And what we have to do, we have to return the results for each query of type 1, right? So we have to return the result for these, this, and this, like this, right? So let's take the first example. We have these connections, so it makes a graph like this, and the queries are as such: 1 comma 3, 2 comma 1, 1 comma 1, 2 2, and 1 2, right? So first we have 1 comma 3. It will give simply 3, right? It will simply give 3. Why? Because 3 is online, so we are good. So this 3 is available. Now we are doing 2 comma 1 for the second query, right? So what I am doing, I am closing this one off. So okay, done. We have put a cross here. Now I am querying 1 comma 1. This one is not available, so the smallest ID is 2, right? So this is also correct. Now I am also closing this with 2 comma 2. So yep. Now I am again querying this 2, 1 comma 2. So we don't have 1, 2, and 3. If we had one, we would have given out 1, but in this case we are having none, like not even 1 and 2. So my answer will be 3, because it is the smallest in the remaining stations. So this is how it's gonna go. And yeah, so now let's try to tackle this question, like how can I move ahead with such type of question, right? So what I'm able to observe here is that we are making different groups, right? And for each group we have, we are gonna have, as we go down the algorithm path, we are gonna have some stations which are active, which are online, and some which are not, right? So for example, like in this group we have 1 3 offline, like they are non-operational, and then 2 and 4 which are available for testing, right? So we are gonna have all of these, and then we have to query the smallest one out of the online ones, right? So somewhere I am getting a feeling that we have to use set, right? So we can do that. And also we are forming a group, right? So we have to know the group ID for each group. And yeah, that's what we are gonna do. We have 1 2 3 and 4, right? So for each group we will keep track of the smallest members, right? So what I will use a set. So let's say we have this, right? So I will assume this 4 will be the parent. Give me 1 minute. This 4 will be the parent, right? This is the parent. Okay, so this whole 4 will contain all the active, all the online elements in increasing order inside a set. So it will be by default in the increasing order. So it will contain 4 also, because 4 is also in the group. So it will have like this 1 2 3 and 4, like this, right? Also we have this group. So let's say 6 is 5 is parent. So I'll just write like this. So it has 5 comma 6 in increasing order. Why? Because we are using set here. Okay, this This is a set. Okay, great. Now what I am doing, if I am performing a query, let's say I am performing 2 comma 1. Okay, so what I will do, if the query is of type 2, then okay, it's good. Now now I have to delete 1. So first what I will do, I will find the parent of this 1, right, which is 4. Okay, now from this 4 I will delete this 1 out, if it exists, of course, right, because it can also happen like we are repeatedly getting this query 2 comma 1 2 comma 1 2 comma 1 again and again and again. So I have to also check if that one already exists to get erased from that set. Now I will just remove this one. Okay, great. Then I am querying 1. Okay, now I am querying 1, but this 1 is not existing. So what I will do, I will first fetch the parent of this one, which is 4. Okay, nice. Now from that one, I will just pick the first element of that set. Like I will use the dot begin function of that set, and my answer will be 2. It's that simple, right? Now let's say I have put an x on all the elements, right? So what will it essentially mean? I have removed all the elements from this group. Now if I am querying any element like 1 comma 3, but the parent of 3, which is 4, that set is empty, it will essentially mean that I have to return -1, because we cannot use any of the stations for operation. So yeah, that's pretty much it, and let's try to implement this now. So first we have to make a vector, sorry, we have to make a graph, and for that graph I'll use an adjacency list. Also, hold on, do we need to make a graph here? That's the question, right? I don't think that we need to make a graph, because we are just gonna make connections, and then we will keep track of the parent, and we are gonna make this table. We are gonna make this hash map, right? So this hash map goes like this: integer mapped with set, like this. It goes like this, right? So yeah, so I'll just quickly write the boilerplate code for the union find algorithm. So, and it goes like this. Also, let's name this C as n, so where n represents total stations, right? So I am going to use union by size and path compression. So this is the pseudo code for it. This is a lambda function. Okay, and this function will connect A and B, right? So so if the parent of both the nodes which we are going to connect, they are same, so we don't need to do anything further. That's classic union find, right? Okay, we are done with the boilerplate code for union find. Now what I'll do, I'll just start making the connections, and let's first make the hash map. So it will look like map integer set mm, what should we name? mm, Members of, right? So let's name it members, right? Now what I will do, I will start populating this members, but first we have to create the connection. So for mm, also these are one indexed, so we have to make them zero indexed. Right, we have connected them now. Now after their connection we have to find the parent. Okay, right, we have connected them. Now what I will do, I will just iterate through all the indices and then push them into their corresponding parent. Okay, so let's say I'll just explain in a minute, right? Members of find I inside I, right? So the parent for station I will be find I, right? I'll just make it more readable. Members of that parent, right? The members which are there in this parent will have this I added to it. Okay, great. Now we can start processing the queries, right? So okay, integer type will be q of 0 integer, right? If this type is equal to 1, if it is of first type, then also let's create a vector answer which is initially empty, right? If type is equal to 1, right? First we will fetch its parent, which will be also let's get a zero index is station, so it will be q like this. So I'll just find the parent of this station. Okay, and I have done that, right? Find station of 0. Okay, parent dot size, then I'll just oh hold on, if this member, if the members for this parent have any available online station, if we have any of them left, so I'll just push the first element of it, because the set is always sorted. What I will do, like this, else I'll just push minus, right? Great. Now if this type is not 1, if it is 2, then I have to let's push this out. Then I will just let's move this also out, right? Now if the type is true and we want to remove this element from its group, from its parent group, then what I will do, like this, right? Then I'll just return answer like this. Okay, we are getting, oh okay, I forgot to add an initializer. Okay, oh, we have to add value at, this is a pointer, then we have to access the value at that pointer, right? So yeah, there are some basic errors, not very big deal. Okay, TLE has come, let's see what has happened. Okay, why is it giving a TLE, which is very weird, to be honest. Okay, I think this find function is, oh okay, so there was a mistake in the boilerplate code, right? Fine. Okay, 0 1 2, okay. Also we have to add okay, members, just give me 1 minute. I think there is some minor error. We will discuss it so within 1 minute. But insert I, okay, this makes sense. I don't know what has happened, but let's see. Okay, so why is it giving, oh okay, so there is a fatal flaw. Okay, I'll just, right, okay, so if that station is already active, if this station 0 is already active, right? So if it is already there, if it is already there, then I'll just simply push that node, right, like this, and then else I'll do all of this. Right, okay, yep, it should give correct answers now. Yep, it looks like it does. Now let's try to submit this code, then we will go through the approach again really briefly, right? Yep, it got accepted. So now let's discuss the approach again. Okay, and I will explain it only here, and I explain it here. Let's collapse these boilerplate codes, so because we don't need them. Okay, so what are we doing? We are first making connections, right? So, and okay, so I am converting them into zero indexing, right? So we are able to use these vectors with clean code. So let's say we have these type of connections, like 0 connecting to 1 is connecting to 2 is connecting to 3 and 3 is connecting to 2, like this, and we have 4 and 5. So we have 6 nodes here. Okay, now what we have done, we have iterated through all of these edges and then we have connected this, right? So first let's say 0 and 1 got connected. Okay, then fine. Then we connected 2 and 1, 2 and 3, 1 3, right? And after all of these connection, let's assume we got the parent as 2 somehow. Okay, that's very fine. Now this is a group which has a parent 2. Okay, great. Then what are we doing? After making these connections, we are making connections here, then we also made this connection, and for this connection we have a parent. Let's say we have 5. Okay, okay, very nice. Now what I am doing is, in this loop what I am doing, I am first, for each station, for each one of them, from 0 to 5, from 0 to 5, I am fetching the parent for each one of them and then storing them into members, right? So what I'm doing, let's say we have this parent 2, right? So I am at 0 initially in this loop. I am at 0 now. For 0 the parent is 2, right? And this parent 2 will have a, as a key, will have a value which is a set. Now in this set I am storing 0. Okay, great. Then I went to 1. Now this 1 also has parent 2, so it will also be added. Then 2 itself will be there. Then we came across 3. Okay, great. Also this list, this will be always sorted because we are using a set. That's why I used a set, so that we get the sorted values, and then I just simply pick the smallest one in case we want to query, right? Now this is done. Then I move to 4. Now for 4 we have parent 5, so I'll just create a key, and for this 5 I will insert 4. Now I am coming to 5. 5 is itself here, so it will be like this. Now we have this. Let's suppose I have queries like such. Okay, I have queries like such, 1 3, then I have 2 1, then I have 1 1, then I have 2 2, then I have 1 3, 1 3, right? We have this. Oh no, let's say we have then 1 2. Yeah, that sounds okay. Okay, now what I will be doing, first I am at 1, we are seeing 3. Okay, now this 3 is available, right? What I will do, I'll just go to its parent here at 2. Now this 2 contains 3, which is this part. Now this contains 3, so I'll just add to my answer 3 plus 1, so it will be 4, because we have to convert it into 1 in indexing, but let's not go there, right? Then we are removing this 1, we are making it offline, so it becomes offline. Good. Now I am accessing 1 1, right? Oh, also as I am removing it, I am also removing it from here. Now we want 1 1, so fetching the parent of 1, which is 2. Now this 2 has the smallest station as 0. Also 1 does not exist in this set, right? So I'll just move here. Now 1 is not there, but we have this size, so that means that we have at least one station which can be used, so it will be stored as 0, right? This is done. This is done. Now I am erasing 2 also. Okay, great. Let's remove 2. Then I am accessing this 2. Okay, we are not having 2, but this is set has a size, right? So, and the first element will be 0, so my answer will be this. So yeah, that's pretty much it. Also, it's time to discuss time complexity of this. Okay, that sounds pretty much good. This union find takes almost constant time complexity. You can read about it, right? It's almost constant, so this loop will be big of this, right? This will be linear, right? Okay, this will be big O of n, and this will be big O of log n sm, right? Because we are inserting in a set, and that takes logarithmic time complexity, right? So in the worst case it is like this. Now this collectively becomes big O of n log n. Okay, great. Now I am doing all these queries, so it will take me big O of this. Okay, this is all constant, this is also constant. Great. This will take, right, this will take also logarithmic time. Okay, this will take logarithmic time, right? So my time complexity in a nutshell will be big O of n log n, sort of, right? So yeah, that was my approach for this question. And feel free to drop any thoughts or any comments or any topic of discussion that you might have, or if you have any doubt with the implementation anywhere in the code, just mention it right away, and then I'll be more than happy to discuss it with you, all of you. And yeah, that's pretty much it. Thank you so much for watching. See you with the next tutorial. Thank you. Bye.